Hi guys, we are now on to lesson 5 from the mole and calculations topic. This lesson is the mole triangle for liquids. Now we have already discussed and practiced lots of examples of the mole triangle for solids, so this is going to be probably a lot more straightforward than it was the first time because we've been through the process already. So our learning intention is to explore the relationship between moles and concentration and volume this time because we are dealing with liquids and solutions. So starter question is to balance the equation before. This is testing previous knowledge from lesson 4, which was balancing equations. So pause the video, give it a wee go, and then check your answer once you're done. So the answer for the balancing equation is 3H2O, it's kind of hard to see that, but that's 3H2O, 2CO2, and then we're going to need 3.5 O2. Now, I think this is an important place to mention that you are allowed to use halves to balance equations, but you can only half the diatomic elements. Now, remember there are 7 diatomic elements. I bring clay for our new house. Iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. Now, the reason that we can half them is because in every molecule there are 2 atoms. So if we split it down the middle, we still have a number of atoms. Now, if we try and split, for example, a water molecule, so if we say we have 1.5 water molecules, that doesn't work because, as we know, we have a structure with an oxygen and 2 hydrogens bonded to it. If we tried to split that, we'd have to half an oxygen atom, and we don't do that. You can't half atoms. So the rule of thumb is the only time you can use halves when balancing the equation is when you have a diatomic element. So what we're going to learn today is to use the mole triangle for liquids. We're going to practice lots of examples, and if we have succeeded, we will be able to calculate moles, concentration, and volume for any compound that we are given. So, what if we want to calculate the moles of a liquid or solution? Not a mass, we want to calculate the number of moles of a liquid. If we want to use the mole triangle for liquids, then we have to have number of moles, which is N, the concentration, or the volume. So this is the mole triangle for liquids. If you haven't already, take a note of this in your jotter. The concentration of a liquid substance is measured in moles per litre. Now this unit is MOL space L minus 1, which means moles per litre. That makes sense because if we were to try and find the concentration and cover that up, we would end up with moles, so N divided by volume, which is V. Okay, so it's the number of moles in a litre, the concentration. You can remember this triangle. I like to remember it by saying chips for C, need vinegar, because I like vinegar on my chips. You can remember it however way you like, as long as you remember it. So how do we use the triangle? Exactly the same as we do for solids, but bearing in mind we are swapping out the mass and GFM for concentration and volume. Now, the volume has to be in litres. Let's go back to the triangle a wee second. The volume has to be in litres. The number of moles is in moles, and the concentration, remember, is moles per litre. Okay? So, if I had a 1 litre solution of potassium hydroxide of concentration 1 mole per litre, how many moles would I have? Now let's work out, using the triangle, our concentration is 1 mole per litre, our volume is 1 litre, our number of moles is the unknown part of the triangle. So if we write that down, we have number of moles equals concentration times volume, N equals C times V, and 1 times 1 is 1 mole. But if we think about it, we have a concentration of 1 mole in every litre. 1 mole per litre means that there is 1 mole of potassium hydroxide dissolved in 1 litre of water. So from that, we should be able to tell that we have 1 mole. When the numbers are not so easy, it's not as easy as that, and it's beneficial to use the triangle. So let's have a wee go at this example. Calculate the number of moles in 200 centimetres cubed of 0.5 moles per litre sodium hydroxide solution. This is much more straightforward than the mass triangle because we're not having to calculate the GFM. So concentration then is 0.5 moles per litre. 200 centimetres cubed must be converted to litres. Now how we do that is we divide by 1,000. If you have something in centimetres cubed and you want to get it to litres, you always divide by 1,000. 200 divided by 1,000 is 0.2 litres. Number of moles is our unknown. So moles equals concentration times volume, N equals C times V. We have 0.5 moles per litre times 0.2 litres, which works out at 0.1 moles. Remember to always add in your units at the end and also double underline your answer once you've finished a calculation. That just helps the marker understand that that is your final answer. Example 2. Calculate the concentration of a 0.25 mole solution of potassium nitrate of volume 500 centimetres cubed. So this time we are being asked to calculate the concentration. Looking at the triangle, we know we're going to have number of moles divided by volume because they are on top of one another. So we have 0.25 as our number of moles, 500 centimetres cubed in litres. Remember, we divide by 1,000. So we have 0.5 litres. Concentration equals N divided by V. 0.25 divided by 0.5 ends up with a concentration of 0.5 moles per litre. That should be not just moles. That's a little mistake. Hopefully you spotted that as well. So concentration needs to be in moles per litre. Here are 4 questions for you to try. I want you to pause the video, try the 4 questions on your jotter, and then unpause and check your answers. Okay, here are the answers. Calculate the number of moles in 50 centimetres cubed of 0.1 mole per litre zinc sulphate solution. So we have our triangle and our unknowns. Moles equals concentration times volume. 50 centimetres cubed in litres is 0.05 times 0.1 mole per litre, and our answer is 0.005 moles. Question 2. The number of moles in 300 centimetres cubed of 2 moles per litre sodium hydroxide. Again, 300 centimetres cubed. To convert this into litres, we divide by 1,000. We end up with N equals C times V, which is 2 times 0.3, and our answer is 0.6 moles. Question 3. What concentration would 1,000 centimetres cubed, which is the same as 1 litre, of solution containing 2 moles of solute be? Now solute, remember, just means whatever we have dissolved in water. So concentration equals number of moles divided by volume. We have 2 divided by 1, which is 2 moles per litre. Question 4, again, concentration. 3 moles of potassium nitrate in 750 centimetres cubed of water. Our C is unknown. We've got our volume, 0.75 litres because we've divided by 1,000 to convert into litres, and 3 moles. Concentration equals number of moles divided by volume. C equals 3 over 0.75, and that gives us 4 moles per litre. So we wanted to be able to calculate moles, concentration and volume for different compounds. Let's have a wee look at our exit task. We have 3 questions worth a total of 7 marks. Number 1 is write the formula for iron 2 nitrate. Now remember, if you have Roman numerals, they tell you the valency of the transition metal. Question number 2 is worth 3 marks. It's calculate the number of moles in 34 grams of aluminium sulphite. So you're going to need to find the formula first, do the GFM and use the solid triangle. Question 3 is calculate the mass of 0.7 moles of lithium nitride. Again, 3 marks, you're going to have to find the gram formula mass, first of all finding the formula and then using the solid triangle. Pause the video, see if you can attempt those questions and then unpause and self-mark your answers. Here are the answers. FeNO3, 2. Your iron has a valency of 2, nitrate has a valency of 1. Swap them, and we end up with 2 nitrate complex ions. Question 2, we have Al2SO3, 3. Aluminium has a valency of 3, sulfite has a valency of 2. Again, swap them and use your brackets. We have a total GFM of 294 grams, so we end up with 0.12 moles. So that's worth 3 marks. 1 for the correct formula, 1 for the correct gram formula mass, and the third one comes from your number of moles being calculated correctly. Same for number 3. Lithium nitride, remember if a compound ends in IDE, it is just the element from the periodic table. So we have lithium and nitrogen. Nitrogen has a valency of 3, lithium's valency is 1. Swap and divide them down, you end up with Li3N. With a gram formula mass of 35 grams, 0.7 moles is therefore 24.5 grams. Very well done to those of you who have worked through those questions and gotten them all right. If you've lost marks, as long as you know where they came from and how to get it right next time, that's what we're looking for. That's the end of lesson 5. Thank you for watching.